Hello everyone, I'm Professor Harrison, and welcome back to our module on statistical inference. Today we're starting a new subunit on hypothesis testing. We're going to cover what a hypothesis test actually is, what null and alternative hypotheses are, and how you build a test statistic from sample data. We're following Bess, an investigative journalist on a cold case you can't let go. And today she's working a case about whether mergers create value for acquiring shareholders or not. To figure this out, she's looking at an academic study that tried to answer this question formally. She pulls up her case file. A hypothesis test is a formal decision procedure. You start with a default assumption. You treat that assumption as true unless the data gives you strong enough reason to reject it. Then you collect the data and ask, is what I'm seeing consistent with that default, or is it so far off that the default is hard to believe? This is the foundation of hypothesis testing. Here, the default assumption is called the null hypothesis. In research and finance, the null is almost always some version of no effect or no difference. It is what a reasonable skeptic would assume before seeing any evidence. The thing you are trying to establish is the alternative hypothesis. It is the claim that you want to prove. The defining property is this. The burden of proof is always on the alternative. The null is presumed to be true. You do not prove the alternative by showing up with data. You reject the null by showing that the data is inconsistent with it. For the merger study, researchers collected data on 100 merger deals. They measured the abnormal return for the acquiring company around each announcement. That abnormal return is effectively measuring how much the acquirer stock moved relative to what the market would have predicted. The null hypothesis is that mergers have no effect on the acquirer's returns. So the null says that the average abnormal return should be 0. The alternative is that the mergers do have an effect, and that the average size is different from 0. That framing is doing real work. The researchers are not starting from mergers probably help, they are starting from mergers have no effect, and here is the evidence that moves us away from that belief. If the evidence is not strong enough, then you end up staying with the null. The claim of an effect has to earn its way in. So now they have a sample, 100 deals. The average abnormal return across those deals is positive 3%. The standard deviation of this is 15%, and the question is a 3% average large enough to actually reject the null? That is exactly what a test statistic is designed to answer. A test statistic takes your sample estimate, subtracts the null hypothesis value, and divides by the standard error. It converts your raw result into a number that tells you how far away your sample estimate sits from the null in terms of units of standard error. The standard error here is the standard deviation divided by the square root of the sample size. In this study, that is 15% divided by the square root of 100, which gives us 1.5%. So the test statistic is 3% minus 0 divided by 1.5%. The reason why we're subtracting off 0 here is because that's our null value, that there's no effect of the mergers on shareholder value. This ends up giving us exactly 2. That number, 2, is exactly what we're going to work with hypothesis testing. The average of 3% is hard to evaluate on its own. Is 3% a lot? Is it a little? It depends on how noisy the data is and how many observations you have. 2, however, gives us how many standard errors away the null is from what we actually measured. It gives us something that we can actually compare against, and it gives us a known reference distribution. This is the reason for converting to a test statistic in the first place. We will cover how to turn that into a decision in the next few videos. But in general, the test statistic is the sample estimate minus the null hypothesis value divided by the standard error. The sample estimate is whatever you measured from your data, the null value is what you assumed under the null hypothesis, and the standard error is a measure of how precisely you estimated the thing that you're measuring. The larger the test statistic, the further the sample is from the null, and the harder the null is to believe. In her article, Bess explains this to her readers. When researchers set out to test whether mergers create value for the acquiring shareholders, they needed a way to decide whether what they found was real or just noise. The null said that the average abnormal return is going to be 0, that mergers have no effect. The alternative said that the average is different from 0, so it basically just says that something ends up happening during these mergers. The data gave them a 3% average return across 100 deals. What's unclear, however, is what that 3% actually means. Is it large? Is it small? So to understand what's going on, the researchers have to convert to a test statistic. The test statistic is what turns the raw empirical finding into something a decision can actually be made on. By measuring the average return in units of the standard error, you end up with a number that sits on a known distribution. In fact, this distribution is one we've already covered, the t-distribution. Under the null hypothesis, test statistics close to zero are what you would expect. Most of the probability density function is near the center. A value of 2 sits out in the tail. So if the null is correct, results further and further from zero are going to become more and more uncommon. So for example, the test statistic of 2 says that it's relatively unlikely that if there's no effect from mergers, that we would end up having this large of abnormal returns. And we wouldn't be able to say anything about the size of these abnormal returns if we didn't have a formal system to build upon. So we define our null and alternative hypotheses. Doing so allows us to compare the real-world data to the null hypothesis to see whether we can reject it and support the alternative. So that's the basics of hypothesis testing. You start with a null hypothesis, the default no effect assumption, and then you add an alternative hypothesis, which is the claim you're trying to establish. The null is presumed to be true and the burden of proof is on the alternative. From your sample data, you compute a test statistic by taking your estimate, subtracting the null value, and dividing by the standard error. That single number is what the formal testing machinery works with.